To the online lectures for software engineering. In today's class, we'll be discussing building the analysis model. Now, within this analysis model, these analysis models, they focus upon what, not how. That is, these models, they focus on how things are done. They focus on what need to be done, but they do not focus on how they are done. So what are the different tasks that are going to be performed? Let's see. It can identify what the system manipulates. Now, what the system manipulates means what type of information or what type of input files it is using and what it is displaying, like what is it taking as input, what it is processing, and how it is going to be displayed. That is what a system manipulates. Then it also is going to tell you what are the different functions that the system should perform or the system must perform. Then what is the behavior of the system? This is identified. And then what interfaces are identified. Now these interfaces can be external interfaces or internal interfaces. So that is going to be defined within the analysis model. And then if there are any constraints that are identified. What are constraints? The limitations. Now these limitations, this can be on the cost. This can be a limitation of specific technology, that the software need to be developed on specific technology, or it can be a limitation of time, that is the software need to be developed within the specific amount of time. So in here, this you can see that all the questions are focusing on what is done, what. So this analysis model is going to focus on what is done, but not how it is done. Now, within here, we are going to study the first topic, that is requirement analysis. Now, within requirement analysis, first we'll study the definition of requirement analysis. What requirement analysis does. Now, this requirement analysis, it specifies the software operational characteristics. That is, what characteristics a particular software might have different characteristics, but what are the characteristics that are operational characteristics? That is what task you're doing, that what operation is performed based upon some specific characteristic. So that is a software characteristic. Then it indicates the software interfaces with other system elements. Now, what are these interfaces? These interfaces, it can either be external interfaces or they can be internal interfaces. Internal interfaces that are there within the system. External interfaces means if you're attaching a specific device, if you're attaching a specific device, that is your external interface with the system. Then it establishes the constraints that the software must meet. Like within the constraint, I've told you the constraints can be of the cost, the constraints can be of technology or people or time. So these are the different constraints. Now this requirement analysis, it allows a software engineer to, the two tasks that are performed by this, those are, it elaborates the basic requirements. Now the basic requirements that are requirements that were gathered within the inception phase, that is the first phase, that are elaborated, that is more detail will be given established during earlier requirement engineering tasks. You're going to elaborate those, like you've got inception and elicitation. Within this, you're going to elaborate all the information that was collected within those two phases. Those two phases, these are from the requirement engineering tasks. The next is you're going to build models that depict the user scenarios. User scenarios means use case diagrams. Functional activities, you can use here the flowchart diagrams. Within here, you're going to call them as activity diagrams. Problem classes and their relationships. You've identified different classes. What is the relationship between those two classes that will be identified. Then what is the behavior of the class that will be identified, and the flow of data, that is flow of data. If you've identified two classes, what is the flow of information, whether the flow of information is going from one object to another or the another object is sending. This is identified. So this is definition for requirement engineering. And the requirement engineering, it helps the software engineering to do these two tasks. Now the analysis modeling objectives. There, within this analysis modeling, you're going to have three different objectives. The three different objectives are: describe what the customer requires. Now what the customer require means what are his requirements within the software that need to be identified. The next one is establish a basis for the creation of software design. Now, establishing a basis for the software design means based upon what? What is your problem statement? Based upon that, you're going to identify the base for developing the software design. The next one is define a set of requirement that can be validated once the software is built. Now, once a software is being built, you're going to have a new set of features. You're going to add new features. Those new features, they need to be tested whether they are meeting the customer requirements or not. So these requirements need to be validated once your software is being built. Now, these are the three objects. Now, this analysis model, it is also going to help to bridge the gap between the system level description and the functionalities. You're going to have the functionalities and you're going to have the description. Between this, the analysis model is going to fill the gap. I'll be showing the diagram for this. Now, coming on to the guidelines. Within this, graphics should be used whenever possible. Now, graphics means you can either make use of models. A graphical representation can be used. You can either use models, you can either use mathematical models. Mathematical models can be used, or charts can be used. So you are going to make use of these graphics. It should be used whenever possible. Now these models are used so that you can more easily understand what needs to be developed. It gives you a clear cut idea of what needs to be achieved. Then differentiate between the logical and physical considerations. Now you're going to have different logical and physical considerations. These need to be differentiated from each other so that you can focus well on them. Then develop a way to track and evaluate the user interfaces. Now within the user interfaces, we've got two types of interfaces. You can either have the internal interfaces and you can either have the external interfaces. So within this, you're going to develop and track and evaluate all of this. Now the person that is going to develop the internal and external interfaces, you're going to keep a track that what is being developed, how there is developed, and whether it is achieving a specific task or not for what it was designed. Now, as I told you, the analysis model, this bridges the gap between the system level description, this is the system level description, and the design model. So this analysis model, this is your bridge. Now, system description means you've gathered this from requirement gathering. From requirement gathering, you know what needs to be developed. Now, based upon what you develop after planning stage, you're going to make a model. So within this, you're going to make use of this analysis model. Within this analysis model, it is going to help you to design this design model. So this analysis model, it bridges the gap between the requirement gathering and the design model. That is, you can say, the system level description and the overall functionality. This design model is your overall functionality. The next one is the analysis rule of thumb. Now this analysis rule of thumb, it was designed by two people, Arlo and Newstead. These were the two people. They have suggested a number of rules that should be followed when creating the analysis model. So these are the analysis rule of thumb. This was designed by these two people, Adler and Newstead. Now these people have told you that what are the different rules that need to be followed whenever you're creating an analysis model. The first rule is the model should focus on requirements that are visible within the problem or the business domain. Now, within this, that is the level of abstraction, that is the level of detail need to be followed. It should focus upon requirements that are visible within the problem. That is, you're not going to keep on digging the more detail. You're going to just give, you're going to maintain the level of abstraction. That is, with abstraction means the level of detail. The next one is each element of analysis model should add to an overall understanding of software requirement and should provide insight into the informational domain, function, and behavior of the system. Now, within the first phase, you've identified what your focus should be on the requirements that are visible within the problem. You can say that is, you're going to give less detail in here, and you're going to give detail that is only necessary for understanding the information domain, the functionalities, and behavior of the system. That is, you're adding some more detail. You're not going to just go into more level of detail that is not required. The ones that are required, you're going to maintain this level of abstraction. Then the next is delay the consideration of infrastructure. Infrastructure is your structure of the software, that how it is going to look like. You need to delay the structure and other non-function model until the design. That is, until you have a blueprint of the design, or you know how it is going to be, what shape and what size it is going to achieve. When you know that, then only you need to begin with the structure and the non-functional requirements of the software. If you go before that, then it is going to create a mess. Then the next point is minimize the coupling throughout the system. Now, what is coupling? Coupling, it is the level of interconnectiveness. Level of interconnectedness. If the level of interconnectedness is high, then you're going to make effort. If suppose this is high, you're going to make effort and you're going to reduce it, because if a software has more coupling, it is not going to be a very successful software. So the level of coupling, it should be low whenever you're designing a software. The fifth point is it assured that the analysis model provides value to all the stakeholders. Now they are going to be different stakeholders. You're going to have the business stakeholders, you're going to have designers, you're going to have marketing people. Each of the people, they need to be benefited by the development of the software. That is, it assures all this stakeholders that this analysis model is going to provide them the best model and it is going to be a big sale. Then keep the model as simple as it can be. That is, you're not going to use any additional diagrams that are not required. You're not going to use any additional diagrams or any notations. You're not going to use any extras. You're going to remove extras so that the model is simple. The next one is domain analysis. Now, what is domain analysis? Domain analysis, it is you're going to identify, analyze all the specification that is within the software. Now, this is done so that you can identify whether these specific features and functions, whether they can be reused for another project. That is the domain analysis. The goal of domain analysis is to find or create the analysis classes or common functions and features that are broadly applicable so that they can be reused. So you're going to identify and analyze all the different specifications that are there within the software and whether they can be reused or not. That is identified. Now, this is the detail. This diagram represents the input and output for the domain analysis. Now, within the input and output analysis, the first one is the source of your domain knowledge. Now, you can see multiple outgoing lines. So I'll be discussing what is each one. First, you're going to have the source of domain knowledge, from where you're getting this domain knowledge, then the domain analysis and the domain analysis model. The first one is your technical literature. Now, the technical literature means you're going to identify what are the pre-existing features. whenever you're designing a particular software, you're going to identify what are the features that are previously available within the market. So when you identify the pre-existing features, that is called as your technical literature. What were the previous applications, what applications had what different functions, that is going to be identified. Then the next is existing application. Now the technical literature is what technology is used, whereas existing applications, now like you can say that when you're going for technical literature, you're also going to identify the different existing applications that were based upon the specific technology. Then customer surveys. Now customer surveys means whenever you're using a particular application, it asks you to rate the software, or you can say that it also asks you to give the feedback for the particular software, what needs to be changed, or whether it is the best software. You're going to have this customer surveys. Based upon the customer survey, the new application that you're designing, you can make changes within the software. That is, you can optimize the software. You can either add some additional features to it, or you can create a more robust model based upon the customer's requirement. And then expert advice. When you've done all the literature survey, that is all the previous things that were already available, what the customer said about this previous technology, you're going to take expert advice. That is what a particular person that is designing some specific sort of technology, sorry, specific software, what is his advice, what is his take on this particular opinion of the particular software that you are developing. Then you're going to take the current and future requirements. Now, based upon this pre-existing applications, you get to know what are the current requirements, that is based upon your customer surveys. Then future requirements means you can say what is required, but what will be required within the future within the software. That is what addition can be made within the software. That is called as your future analysis. Within your mini projects you've done, after conclusion, you write the future works. That is the same way. That is your future requirements. That is the source of your domain knowledge. Then this is input is given to the domain analysis. Now this within those domain analysis, the output is the class taxonomies. You get to know the different classifications. Taxonomies are classifications. So based upon that, you're going to identify the different classes that will be there within the software. Then reuse standards. When you know the previous technology and existing applications, whether any features can be reused or not, you can identify the reuse standard. Now when you are making use of reusable components, it is going to reduce the cost and it is going to reduce the time when you're reusing specific components. The next is functional models. Now functional model means what are the different functions that you are embedding within your software. You're going to identify those. The additional features will be identified. Then you got the domain language. Now the particular software that you're designing, on what programming language it is based upon, you're going to identify that. Then you get the domain analysis model. Based upon what domain, you're going to study all the things that were existing, then what are the things that you're adding now, and what are the things that you're reusing. That leads to your domain analysis model. So this is the domain analysis. Now coming on to the next topic, this is your analysis modeling approaches. Now this particular answer is important for 10 marks. Now within this analysis modeling approaches, first we are going to just study only the main approaches. After that, we are going to study those in detail. So the first we'll begin with the elements of the analysis model. Now within the elements of the analysis model, there are two approaches within the analysis model. The first approach is the structured analysis. Now within the structured analysis, the data objects are modeled in a way that defines their attributes and relationships. Now within the previous classes we have studied what are attributes and relationships. For a particular class, you're going to have a name. For if suppose we are taking a class name as a person, for the particular person, the attributes can be his name, it can be his identification number or phone number. These are your attributes. This is your class name. This is your attributes. So you're going to identify different data objects. They are modeled in the way so that you know the different attributes of those data objects and the relationship. Now they are not going to be only one person. They can be different persons, and what is the relationship that exists between these two persons, that can be identified. The second one is, it is a process that manipulates the data objects in a manner that shows how they transform data as data objects and flow through the system. Now, whenever you're making use of a particular data object, now this data object is going to have some specific information. Now this information, it can be used, or this information can be processed, and it can be taken as input for some another entity. That is, output of this becomes input for another entity. So this is called as your structured analysis. Whereas the second type, it is your object oriented analysis. Now within this object oriented analysis, this focuses upon the definition of class. Now in here, within the structured analysis, we have taken the attributes for the particular for the person. Whereas in object oriented analysis, you are going to focus upon the definition of classes and the manner in which they collaborate with one another, how they are communicating, that will be identified, how the communication is taking place. Then UML is predominantly object oriented. Now what is UML? UML is unified modeling language. The different diagrams that we'll be studying within the syllabus. Use case diagram we have already studied. So these UML diagrams that you're going to use, those all diagrams are called as the object oriented diagrams. Now coming on to the different elements, I've told you there are 4 different elements. Now these 4 different elements, the first one is your scenario based element. Within the scenario based elements, you're going to have use case. Use cases as text and use case as diagram. Use case as text means you're just giving a description of what you're going to create within the use case model. Then use case diagram is the actual use case diagram. Within the use case diagram, if you remember, you're going to make use of different actors and you're going to show what are the different tasks that they are going to perform. Those will be represented within this oval boxes. That is a use case diagram. Activity diagrams, these are similar to your flowchart diagram that we have drawn within C. Within C, you have drawn different activity diagrams. Swimlane diagram, it gives you more level of detail as same as your activity diagram. We'll be seeing this in detail. Then coming on to the flow oriented elements. Flow oriented elements, you're going to have how the information is flowing, that will be identified by the name itself. You can say that flow oriented elements are going to say you how information is flowing from one object to another object. Here you're going to have the data flow diagrams. This is called as DFD. Control flow diagrams, how the control is moving from one object to another object. Then processing narrative means this is going to be basically text. Then behavioral diagrams, here you're going to see state chart diagrams and sequence diagrams. Then within class-based element, the state chart diagram we have seen an example within building the use case models. Then class-based elements, you're going to study class diagrams, analysis packages, CRC models. CRC is class responsibility collaborator models, and collaboration diagrams. So within this, so these are the different diagrams that are going to be there. Now within the exam, what it can ask you, it can ask you to explain scenario based elements for 10 marks. Now when it is asking you to explain scenario based elements, you're going to tell within scenario based elements, you're going to have these 3 different types of diagrams: use case, activity, and swimlane diagrams. You can take a small example and draw small diagrams for this. Or it can ask you to explain flow oriented models. In flow oriented models, you can either explain data flow diagram or control flow diagram. Either one of this can be explained. In behavioral diagrams, you need to mention that there are 2 diagrams, 1 and 2. Within this flow oriented diagram also, you're going to mention that there are 2 types of diagrams, and 3 are there in scenario based elements. Now speaking about behavioral elements, 2 are there. What is state chart diagram? You're going to define it and you can explain it with an example. The same is for class based elements. This is for class based elements. Now these 4, it can ask you individually for 10 marks. We'll be studying this in detail after we cover a few important topics before we go within this topic. Now, coming on to data modeling concepts. So the next topic is data modeling concepts. Now, what are data modeling concepts? Now, these data modeling objects, analysis model, this begins at data modeling. That is what type of data you're using. It depends the software that you're designing. First, you need to identify what type of data is used by that particular software. That needs to be identified. So these data models, they consist of 3 things, that is the data object, attributes, and relationships. We'll see what are these. Now these data object, the definition of data object is a data object is a representation of almost any composite information. Now what is this composite information? This composite information, it means that the number of different properties or attributes of a particular system. This is your composite information. So this data object, it is going to represent any attributes or properties that can be understood by the software. Now the attributes and properties that can be understood by human are different, and by the software that can understand, those can be different. Now this a data object, it can be an external entity. Now example of external entity, it can be either the producer or the consumer of information. The person that is either making that information or the person that is making use of that information. Those are called as your external entities. Then the next one is it can be a thing. Now what can be a thing? Examples of thing is it can either be a report or it can be a display, any image. Then the next one is it can be an occurrence. What is an occurrence? An occurrence, it can be an occurrence of a telephone call. Then the next one is event. Now an example of event can be an alarm. Then the next one is role. An example for a role, it can be a salesperson role. Then the next is an organization unit. Now in an organization unit, it can be either the accounts department, a warehouse. Then the next one is it can be a place. Now a place, this warehouse is the example of place. Then a structure, it can be a file. So this is the data object. Data object, it represents any composite information that can be understood by the software. Composite information means either the properties or attributes. Then these are the different examples of data objects. It can be either the producer, consumer, a report, a telephone call, an alarm, a salesperson, an accounts department. So these are the different examples of different data objects. Now coming on to this another example. For example, we are using a set of attributes that can be defined for either, you can define this for a person or a car. Here we are taking an example for a car. Now this car is your data object. Now within this car, you're going to make a table. Now this table is going to have like what is the model of the car, the ID number, the body type, the color, and the owner. Now selecting this particular instance, that is this particular row that is highlighted. Now this particular row is highlighted. We are using the car Corvette. It has got a specific ID number, body type, color, and the owner. Now within this, there are different types of attributes. Now this attributes will be studying within the different attributes. Now identify, that is a unique identification number. This identification number, it is unique for all cars. So this is called as your identifier. Whereas descriptive attributes means the body type and the color. This is going to describe how the car is going to look like. Then referential attributes. Now this referential attribute, it means who is the owner of this particular car. Those are called as your referential attributes. Now these referential attributes, you can take this referential attributes from another table. You can have another table that has got all the owners for the different models of the cars. So based upon that, the owners, this is your referential attribute. Now this ties one data object to another. In this case, that is the owner. As I told you, you can have another table that is therefore only for owners, or it has got many more different fields. From that different fields, we are picking one field that is referential attribute. Suppose this is the field, so you're going to make use of that. You're taking a reference from another table that is called as your referential attributes. Now the maker of this particular car, the model, and the ID number, these three things are called as your naming attributes. Now data attributes, they define the different properties of a data object and take one of the three characteristics. Now within this, you can this defines the properties of the data objects, and it can have either of this three characteristics. From this first, second, and third, you can have any one of them. Either you can have the first one or the second or the third one. Now what are these three different characteristics? These data attributes, it can be used to name an instance of the data object. Now naming an instance of the data object, now this is one specific instance for a particular car, Corvette car. You've got this specific instance. Now for this, so you're naming one instance of the data object. This is one particular instance. You're naming this particular instance, the maker of the car, the model, the ID number. This is your one instance. Whereas describing the instance, now describing the instance means these are your descriptive attributes, the body type, the color. These are your descriptive attributes. Then making reference to another instance in another table, those are your referential attributes. So these are the different types of attributes. You can name the instance, describe that instance, and make reference to another table in another table. These are your referential attributes. These are your descriptive attributes. And this is your naming an instance. You're selecting one specific row. Then the next one is relationships. Now the relationships, you can have different data objects, and how these data objects are connected to one another, that is called as your relationships. Now within here we consider two data objects. Now this one data object is your book and another data object is your bookstore. A connection is established between the book and the bookstore because two objects are related. Now a book, when you have a bookstore, a book will be available. If you've got multiple books, they need to be placed within the bookstore. Like this is the idea. Now within this, to determine what is the relationship between this book and the bookstore, you need to study this. There can be different roles for this book within the bookstore. Now this book, a particular book, can be ordered from a bookstore. This is the first role. The second one is you can put the books on the display within the bookstore. Then you can have stocks of books. Those can be either supplied to another vendor or you're storing it for yours at your end. Then you can sell the books within the bookstore, or you can also have some returns. When a person purchases the book, the particular person can also return the book. Now that particular book, it can have the return policy for a specific for a few days or something like that. So these are the book and data store. These are the different data objects, and how these data objects are connected, those are called as your relationships. They can be different types of relationship between the two different data objects. Now the next topic is cardinality and modality. Now these are some additional elements within the data modeling. Now within data modeling, we studied different data objects. You've studied the attributes, and we have studied the relationships. The next is cardinality and modality. This is an additional elements to this data modeling concept. You can have an object X that is related to object Y. That we have taken example like book and bookstore. Now you have a relationship that exists between a book and bookstore. This is not enough to give you enough information. So within this, you're going to have cardinality and modality. Now what is cardinality? Cardinality is the specification of the number of occurrences of one object that can be related to the number of occurrences of another object. That is how many times an object is related to another object that can be identified. Now cardinality is expressed in one or many. Now you can either have a one-to-one relationship, or one to m means many, one to many relationship, and many to n number of occurrences. So one to one means one object is related to another object. One to many, it relates to many objects, and many to n, some number of occurrences, they are related to some other number of occurrences of another object. This is called as your cardinality. Now this particular answer, cardinality and modality, this is important for 2 marks or for 3 marks. Define cardinality and modality. The next is modality. Now, cardinality does not provide an indication whether or not a particular object can participate in a relationship. For that purpose, we have got modality. Now, within this modality, you're going to have two values. You're going to have either the value 0 and you're going to have the value as 1. It can be 0 value or it can be 1. Now, modality of the relationship is 0. That is, if you've got two objects, you've got book and bookstore. Now, if suppose the modality is 0 within for this relationship, if this modality is 0, it means that there is no need for relationship to occur. There is, if suppose the relationship does not exist, that is, if suppose you've got this two objects, if there is no relationship between them, that is fine. If the relationship is 0, that it is optional. You can say that the relationship is optional. Whereas if the modality is 1, it means that the relationship is mandatory. It needs to exist. So this example, this can be for 0 and this is for 1. This is cardinality and modality. The next is object-oriented analysis. Now this object-oriented analysis, it is again important for 2 marks. Now object-oriented analysis. Now this object-oriented analysis, short form can be OOA, object-oriented analysis. Now the intent of OOA is to define all the classes that are relevant to the problem. That is, the classes that provide some specific information that is useful to the problem. Only those classes, you're defining those classes so that they can solve a particular problem. Now to do this, to perform this task, you're going to have a number of steps that need to be followed. The first step is basic user requirement must be communicated between the customer and the software engineer. So what is the user requirement? You need to identify that user requirement. That user requirement can be identified by communication. That communication is done between the customer and the software engineer. That is the person. It is done between two people. That is your stakeholders and end users. When there's communication between stakeholders and end users, you get to know what is the basic requirement. Then the next one is classes must be identified. Now, what are the different classes? That is, you're going to identify the different attributes and methods will be identified. Now, class diagram within the classes, it is going to tell you what is the structure of a particular software that you're developing. So you're going to identify the different classes. The next is a class hierarchy is defined. Now, class hierarchy means you've within the previous class you've studied business process engineering. Within that, you've got some different levels of information that is developed. So class hierarchy needs to be defined. Then the next is object to object relationship should be present. Now, object to object relationship means whether you're going to have association relationship, either dependency is there. Association means direct link, association. Then generalization means it is making use of functions that are already there within some other. That is, it is inheriting some specific features. So there are different relationships. You need to identify what is the relationship between the two different objects. Then object behavior must be modeled. That is, what is the behavior for a particular object that need to be identified. Now this all tasks from 1 to 5, they need to be applied iteratively until the entire model is complete. That is, this 1 and 5, this is going to be on repeat until the entire model is completed. You're going to identify the user requirements, identify the classes, make a class hierarchy, identify the different relationships, and identify the behavior of different objects. Now you're going to complete this until the entire model is completed. Now that's the end for today's class. We'll be studying scenario-based modeling within the next class.